So database engines are notoriously difficult to test, largely because they have such massive surface area, and tests that are driven through SQL, such as Postgres typical tests, it's very difficult to cover all the little corners and edge cases of the different subsystems, especially when you're dealing with transactions and transaction ranges, where in cases of transaction overflows and stuff, it's difficult to get systems into that state in a quick, testable way. So here's a look at refactoring code to make it more testable. So we have to do some surgery inside Subtrans, and I wanted to be able to test it really well. So I looked at Subtrans, and there's a few modules in the engine like this. CLog, anything that uses an SLRU is like this. And I said, well, this thing is like a class. The Subtrans is like a class, and there's always like this Subtrans coddle or CLog coddle. That's like the this pointer to a class, right? So if you think of it as a class, and you think of the global as like the this pointer, why couldn't you have other instances of that class? And so we refactored our code so that we could stand up multiple different Subtrans subsystems at the same time, the real live one and then test ones. And so here's an example of some Subtrans code. This is the Subtrans get parent method as it exists right now. This is a public external API from Subtrans, and I've highlighted in red some of the global variables that it uses. Refactored all the public APIs so that they remain the same, but then they call the internal routine passing in the global control structure. The internal routine doesn't use any global variables, it just uses the data that's passed in. And then we could write test wrappers as well. So the public API would call lowercase Subtrans set parent passing in the global, and then test Subtrans set parent passes in some test data structure and then calls the same internal API. So now we can do initialization of multiple Subtrans subsystems at once, the regular startup Subtrans and then a test startup. Again, all the actual code is factored out so that it's not assuming any globals, but the external APIs are kept the same. So anything that calls Subtrans doesn't change, it's all the same. Then we have some test macros, like here's a macro to get and set a random Subtrans. You don't worry too much about the specifics because there's some other code change here that might not make sense, but the idea is just a test function. It gets a random transaction ID in Subtrans, sets it in the Subtrans subsystem, and then asserts that it gets the same data back. Very simple. And then we can write larger actual tests that go through and initialize a Subtrans subsystem, generate a bunch of random data, check consistency, at the end assert that the thing is fine, and tear it down. We can even make up current portions in the transaction ID clock because we've refactored that out. So we could do tests specifically, write it wraparound from a system that's called, and then we wrap this in a extension that we called APG unit. And so we can just select unit test, and then it calls all these C functions, which go in and stand up Subtrans subsystems, exercises different unit tests, gives you the results, and that's it. So that's the end. Just a different way of looking at refactoring code to make it more testable in Postgres. Thank you.